We're going to look at two triangle theorems in this video, and they are two that are pretty obvious and ones that you probably wouldn't even question at all, but we're going to go through so that you know how to work problems that are related to these two theorems. Just in an effort to save time in the video, I've already pre-done a portion of it. So you will likely need to just pause the video so that you can get what you need written down. And then once you have it written down, just pick the video back up so you can hear and understand the explanation. All right, so the first theorem that we are going to look at is the triangle proportionality side splitter theorem. So what this theorem says is that if you have a segment that's parallel to one side of a triangle, then the segment divides the two sides proportionally. So I have an example of this, and again, I already have it worked out, so I'm going to try and cover up my answer here. So here is an example of this one. So if you look at this triangle right here, so we had this triangle, and then this segment SV, is parallel to the side of the triangle. So those two segments right there are parallel. That's what those little arrows mean. So SV is the segment that's parallel to one side of the triangle. Well, if those two are parallel, then it's going to split, this segment SV is going to split those sides proportionally, which means that we can locate or figure out the missing side just by making a proportion. So what we want to do is find the length of VP, which is this. Now, there's a few different ways to do this. There is a wrong way to do it, but there's more than one right way as well. But what we want to do is make a proportion out of these measurements. You might wish to do the left side over the right side as one proportion, and then 15 over x as the other proportion. You could go the opposite way, where you're saying 28 over 24 and x over 15. I often just think of this segment as being like the fraction bar. So I have 24 over 15 equals 28 over x. And that's the one that I went with for this example. So I started off and said that 24 over 15, which would be the two pieces on this side, are going to match up with 28 over x, which are the two pieces on that side. I simplified this by 3, which gave me 8/5, and it's not quite as obvious how 8 will become 28, so I just went through the steps of solving. So multiply the diagonals together, and I got that 8x equals 140. Divide both sides by 8, so x is 17.5. So that tells me that this side length right here is 17.5. Now I want to take a minute just to show you what is not an appropriate proportion to set up. If we, and why you would do it, it doesn't even make sense to me, but if you said 24 over 28, you would not say x over 15, because the 24 and the 28 are going from left to right, and then the next proportion you have going right to left. So that one would not work. Another one that wouldn't work is if you matched up 24 with x. So let's say you did 24 over 15. That is not going to match up with x over 28. So again, that wouldn't even make sense, but just to show you what wouldn't work. But again, there's more than one way to set up a correct proportion. Okay, now the converse of that is true. So what that means is that if we look at the problem in the opposite way, if we find that the sides are proportional, then that tells us that the segment is parallel to the side. So basically, it's the statement going in the opposite direction. So I have an example of this, if I can fit it all on here. Let's see here. Okay, so the question is, if BD is parallel to AE. So what we're going to do this time is we're trying to decide if these two side lengths right here are parallel to each other. So here's our triangle, and then we have this piece right here, and we'll know that these two are parallel if we can write a proportion with these sides. All right, so again, lots of different ways that we can write a proportion, but I'm going to go with, and again, I like to just often use that as a fraction bar. So I'm going to say 98 over 119. I want to know if that is the same proportion as 70 over 85. And again, this is just one way to set it up. There are other ways to set this up. Well, just like we used the cross multiplication up here, I'm going to do the same thing right here. So I'm going to multiply the diagonals together. So if we multiply 119 by 70, we get, so we multiply those two together, and we get 8330. All right, now if I multiply these two diagonals together, if we get, oops, dropped my cap. If we get the same amount, then we know that the proportion is true. So if I multiply these two together, I again get 8330, which is equal. So since the proportion is equal, then yes, I know that this side is parallel to that side. All right, one other example to show this that is one that is a little different from the others, but still doable. You just have to think about it because there's more than one way to set up a problem. So in this example, example 3, I can see that these two sides are parallel, which tells me that these two and those two are going to be in proportion to each other. So I know this is 4 and this is 12. I know this whole piece right here is 20. I know this is x. Now, if I knew what number that was, I could use simple subtraction to figure out the other piece. I could write an algebraic expression, or I can set up a proportion in a different way. So what I'm noticing is that x and 12 match up with each other. So I'm going to say x matches up with 12 because that is the top part here on each side, so x and 12. The only other measurement I know on this side is 20, and 20 represents the length of the whole side. So the measurement that I need to put over here needs to be the measurement for this whole side, which would be 16. All right, I like to simplify, and both of those can be reduced by 4. So that's going to be 5 over 4. So using pretty simple math, I can tell that x is 15. All right, so that takes care of the triangle proportionality theorem. So next up, and again, just to save time, I am going to start, I already have the other theorem written out, so you just need to pause the video so that you can get the statement written out and then you can resume the video. All right, the midsegment theorem says that if a segment connects the midpoints of two sides, then the segment is parallel and half the length of the third side. So I wanted to draw this one live for you. All right, so we're going to start off with a triangle here. So here's our triangle. And I'm going to just call this ABC. So here's ABC. Now, I'm going to get a segment that connects the midpoints of the two sides. Well, the midpoint is the point in the middle. So the midpoint of this side might be right there, which I'm going to call D. And the middle of this side is probably somewhere right around there, which I'm going to call E. And I'm going to connect those two as my segment. So I made a segment that connects the midpoints of the two sides. Well, if this point is the midpoint, then I know this side and this side have to be the same length, because that's just the definition. And if E cut this side, if E is in the middle, then I know that this side is going to be congruent to that side. So a segment connects the midpoints of the two sides. Well, if these two are, if you look at them symbols alone, we can already tell that they're going to be proportional, which means that this is parallel to this. But the other thing that it means is that side or segment ED right here is half of the length of BC. So if I move this up here, BC is going to be twice the length of DE. And it completely makes sense, because if this side is half of that and this side is half of that, then this side would be half of that. But here's what's really cool, is that we can do it all three ways. So let me turn my paper this way. So I'm going to say that the middle of this is right about here. I'm going to call that F. So if this is the middle of that side right here, then this is the same length as that. And there's my midpoint. All right, then I'm going to turn my paper again. This is getting crazy here. And these two are the midpoints of those two sides. So if I connect them, then I know that EF is half the length of AD. All right, so now let's go back to this. Okay, if DE right here, or ED, whichever one you want to call it, is half of the length of that, then I know that this piece right here is the same as one of those. So this piece is the size, whoops, I meant to do red, is the size of this one. So this piece right here is the length of that piece, which is also the same as the length of that piece. And then if we turn our triangle again around and we look at it going, yikes, trying to get it straight on the camera here. We'll do this one, I guess. All right, so now if we look at this one, this piece right here, which is DF, is half of AC, which means it's the same as AE or CE. And then if we turn it around again, and again, trying to get this so it looks right on the camera, this right here, which is piece EF, EF is going to be half of AB, which makes it DB or AD, whichever. So if you look at this, in this triangle right here, which doesn't have to be an equilateral triangle, it looks like it, but it doesn't have to be, I have four congruent triangles in here that are all similar in size. In fact, they're half the size of the large original triangle. And that is very cool. So here are some problems that we could do with this. So using this picture without redrawing another one. So I'm going to, I'm going to pause this. Oh, wait, maybe I don't need to pause it. Never mind. Sorry. I was looking at the time, but I think I'm okay. All right, so for example 4, if I told you that AC was 20, then I want you to tell me how long is DF. All right, well, if we look at this, if AC is 20, that means this is 10 and this is 10, which means DF is also 10. All right, let's say I told you for another one, let's say I told you that DE is 7, so how long is BC? Well, if DE is 7, then I know that BC is 2 DEs, which means BC would be 14. All right, now we're going to do one that has an equation to it. All right, so let's say that, so for example 6, let's say EF is 3x plus 7, and AB is 7x plus 6. So I want to know how long is EF. That's the question there. All right, so if we look up here, so EF is 3x plus 7, and AB is 7x plus 6. Well, here's the deal. 2 ways we can do this, and it doesn't matter, although I think one is easier than the other. But we know that this piece is half of that. We also know that this piece is 2 of those. So all we need to do is translate that into an equation. So just to write this out in words, I know that EF is half of AB, but then I also know that AB is 2 EFs. And I prefer this one. The reason I prefer this one is that I'm not into taking half of that. All right, so here goes. Let's try this one. So AB, which is 7x plus 6, is equal to 2 of these, which makes 6x plus 14. So AB, so this is AB, is equal to 2 EFs. So now we can just solve. So subtract 6x from both sides, we get x. Subtract 6 from both sides, we get 8. So now we know x is 8. The answer to this isn't 8, because what we need to do is fill this in. So the answer to this, so EF, is now going to be 3 times 8 plus 7, which is 31. All right, I think that probably covers what you need to know about this. And again, if you need to go back and rewatch the video for a better explanation, please do before starting on your assignment.